Yeah, thank you so much for having me. It's a pleasure to host Dr. Chris Fourie as well for the CoE-MaSS. Yeah, I mean, where do I start? Let's say Chris is a qualified medical doctor. I mean, but he's currently focusing on industrial artificial intelligence. He works at LifeQ. So Chris and I met in 2019 when he attended the Ibro Simons Computational Neuroscience in BIZO. And he was clearly passionate about neuroscience, AI, health, and most importantly, communities. We've become friends and community colleagues over the years in a number of different ways. And Chris has shown a deep desire to better health from a very technical perspective while considering the people who are actually impacted by the tech. Since then, he has become a community leader of resource-scarce, the deep learning Indaba in Tunisia, Tunisia last year and then Ghana this year, and as well as the deep learning Indaba X South Africa. He recently co-founded the community collective Grassroots Party.Africa website, and this is to support and connect grassroots participatory communities. And currently the communities that they're supporting and connecting include Resource-scarce, Masekane, and Roya. And this is across Africa. So Chris is passionate about people and technology, with particular focus on making the latest advancements in AI relevant for healthcare in a very African context. With this in mind, he did found Resource-scarce with some others to build a distributed Pan-African community that aims to improve local communities on a global scale. I'm not going to give too many spoilers away, but I will say in this talk, he aims to explore the challenges that productionizing AI for healthcare systems in Africa has, and progressively he will step through the complexity of many of these systems, offering personal insights, and especially those that he has found most pertinent, he will tackle. So he will also be talking about the grassroots collaborative research approach to help solve, ameliorate some of these challenges in resource-scarce contexts that we are all familiar with throughout Africa. And this will be discussed in relation to the OneHealth Global Health Initiative for multi-scale collaboration, and also try to address some of the challenges for implementation of this idealism. But yeah, Chris, with that, it's lovely to see you, lovely to hear what you have to say. And yeah, look forward to it. Over to you.
Yeah, thanks, Chris. That was an absolutely superb introduction. I really appreciate that. As Chris mentioned, I'm going to be chatting today about AI for healthcare introduction, specifically looking at the African context. So often I attend a conference and hear a lot about AI for health. And there's always like a lot of really superb, fascinating things going on. And my first question is always, how are we going to make this work in the real world? How are we going to productionize it? How are we going to get this? So, as Chris mentioned, I've been working in the space of AI for health. And what I intend for this talk to be today is really kind of like the starter pack for individuals who are interested in exploring going into business in this space. And if you are a startup looking to take your perhaps research ideas and put those into production. So just a little bit on my journey. I think Chris has done fairly well from healthcare to machine learning. So I qualified as a medical doctor in 2014. This is a little bit of a map of how I got to where I am now. So one of my very first grassroots initiatives in community was hoping to reestablish the South African Medical Students Association around 2013. That was also an introduction to the International Federation of Medical Students Association, as well as concepts around like global health policy. However, right after my medical degree, I didn't want to practice medically. I was more interested in science and also biomedical engineering. I went and did like a year of engineering. However, I quickly found that doing a second undergraduate, especially when your first undergraduate is 6 years, is not a great idea. So after that, my interests really were in computational neuroscience. I got a great introduction to that at the BIZO, as was mentioned. I have then been a part of the rail lab at the University of the Witwatersrand from 2019. That was also my introduction to the deep learning in Java, which helped me get a job at LifeQ, which is a company based in Atlanta. There, I work as a research engineer. I sit sort of between our science team and our cloud engineering team, and I do a lot of machine learning engineering and software tuning for research on time series continuous monitoring health data. So a lot of the work there is on like wearables or how do we get health insights from that, as well as how can we connect that to other continuous monitoring devices like a monitor, for instance, and combining those signals to get a more comprehensive diagnostic picture. Through the deep learning Java, I was also introduced to the Java X. Through that community, we also started the Sisonke Biotic grassroots participatory community, where we can make machine learning and healthcare research in Africa as accessible as possible. And then recently this year, we started a community collective or a community of communities called the Women Grassroots Party. More about that later. So my particular research interests, I would say, are in like the applied and fundamental spaces, are fairly different. So in the applied space, it's really machine learning healthcare. In the fundamental space, though, it's more around collective intelligence and multi-agent system modeling. So my own research with the rail lab is during my computer science masters was in multi-agent reinforcement learning, looking at like biological alternatives to back propagation. But enough of that. So yeah, machine learning and healthcare introduction for Africa. My goal for this talk is really to try and help increase in any way the success in both research and industry spaces in Africa. The way I like to do this is first try and set the expectations for the space, then share some of my experience in it, and then tell you a little bit about some of the endeavors along the way. And yes, I will try very hard to get 3 E's there. Anyway, so where are we at? I think especially with like a lot of the large language models, the hype train in AI in the industry space is in full force. It has no rates. You can see even though from like 2018, we have 63% of about 1,000 US managers from the Deloitte survey saying that they had plans to deploy AI or machine learning in their business. Just as an example. However, the reality is, and this is from more recent surveys, that we only see, at least from this particular survey, about 14 to 26% widespread deployments. If you look at other surveys from these consulting companies, KPMG, we also see fairly dismal, what they call at least moderately functional deployment of AI for healthcare companies globally. And here is more of a comprehensive survey from IBM, where the blue is what has been deployed and the purple is what's being deployed. So you can just see this massive gap between essentially what I would call like research and exploratory space and things that we actually see working in the wild that are products that can be used one way or another. And the reality is that machine learning is hard. There are a number of reasons for that, but here's a very like canonical image around that. This is from a paper in 2015 with the hidden technical debts in machine learning, and basically that little square there, circled in red, that's our machine learning code, and everything around that is the software production code that we need to make this run smoothly. This is something that people often forget about. And then people also forget that that system has to exist in the world, right? You can't just expect a functioning system, especially in the healthcare space, to function in different contexts across the world. So also, healthcare is hard. This is from a paper looking at the challenges of generally putting healthcare machine learning into production. I'm not going to go through all of those topics. This is more just a reference. The point I'm trying to get across though is that there are just layers of complexity that we need to consider when moving into the space. And especially in Africa, resource scarcity is hard, and these are particular challenges, specifically for deploying ML in a resource-scarce environment in healthcare. So another layer of complexity. And I mean, there's maybe one or two things that I will just highlight there, also from my personal experience. And often, especially I guess in the African context, we hear politicians saying, let's do 4IR, and like answer to that is we can't really do 4IR until we go 3IR. We don't have the health data, and it's not accepted. We're not going to be able to do any kind of health data analytics. Of course, like funding is always a problem. Government regulation is something I'm going to go into a little later, and that also is not where it could be or it should be. And just touching on capacity there, I can say that when I was training as a medical doctor, we had like very little incentive to explore research, not even like AI research, it's like research in general. And I think the feeling that I got mostly was we're here to try and keep these health systems running, because I think in any resource search environments, the medical professionals rarely have time for sleep, let alone doing research on the side. Just like at the point to make there. So I do think that we have some reasons to be optimistic. These are just like a sample of companies in Africa that are doing machine learning in healthcare. The way I've set this up is roughly putting like companies that do like collection of data at the bottom, some of the interoperability in between, and like the AI things at the top. So for instance, like OneHealth, having Gap Health, these are all doing great work in digitizing patient data. The Fire and HR, those are African projects. However, they are really important interoperability standards that have been emerging. Fire more from the US context, OpenHR more from the European context. And then CoE-MaSS is a South African, very recent non-for-profit in the private space that is working to make health data interoperable. So the fact that that's in kind of a non-for-profit capacity and that someone is doing it is just great news. And then we have like just a whole handful of great African companies doing various types of machine learning, from computer vision to continuous monitoring to natural language processing for medical personnel in African context, with African accents, that's Intron. Yeah, I mean, it's to be done some great stuff. They recently got acquired by BioNTech for something like 700 million pounds, so that's a great success story. And that's more like proteomics. So this is a fairly well-used African proverb, but I really think this is what we need to think about. Is if you want to go fast, go alone. If you want to go far, you've got to go together. And what I really like is it seems like WHO and friends has really taken that mentality to part, where previously the traditional way of conducting global health, for instance, was in a very top-down manner. However, there is research to show that this is consistently, while it is consistently delivered on the economic goals, it is also consistently failed in delivering on social goals. And what this OneHealth initiative aims to do is bring together not only the healthcare, traditional healthcare industry, but also veterinary sciences and ecological sciences, because all of these things impact our health. And it is a multi-level, multidisciplinary type of approach, which I think is great. However, and this is again just a very, for your reference, a definition of what OneHealth is. You have access to my slides if you want to do this. But the point there is it's multiple sectors, participants, communities, at varying levels of society. However, collaboration is also hard. So I've referenced a paper here that has 21 challenges for the implementation of OneHealth. And think there, one of the reasons to be optimistic is, I think I talked about it at the end of the time, is there just a outgrowing at the moment of or emergence of these grassroots participatory research collaborations, specifically in the computer science and machine learning space. But I do think that this mentality is starting to grow. And while I don't think that grassroots initiatives are the be all and end all, I do think that if we're going to achieve something like the OneHealth approach, we're going to need top down, bottom up, and everything in between. So this is just one more complementary puzzle piece, and we need to be optimistic. These also just some great research collaborations in that space. BSI Africa is going since H3 Africa and we for a long time. And the African Health Research Institute has been collecting public health data for the past 20 years. And is currently hiring for the data science team if people are interested in that. So if you are a startup and you want to get started in the machine learning healthcare space, where really do you start? Often people will say with funding, and yes, funding is really important, and it's very hard to do anything if you don't have funding. However, I think if we're talking about healthcare, we really need to talk about how the conversation start at responsible AI. Responsible AI isn't all that well defined. However, I have been able to find a good definition for socially responsible AI. I think is a little bit more concise. So socially responsible AI is a human value-driven process where things like fairness, transparency, accountability, reliability, safety, privacy, and security, inclusiveness are the principles. So when we're thinking about healthcare, if we want to make it work in the real world, I think we have to start with the people it's going to affect, and are we doing this in a responsible way? Because I think that not only makes ethical sense, it also makes really good business sense. Here's just an extension to that definition. It's like a two-part definition. That means put it in the paper. I won't get to this instead of your reference. Again, why I particularly like that two-part definition is because there you'll see a lot of different words thrown around in the responsible AI space, like robust AI, AI, trustworthy AI. These are all definitions for those words. But why I like this one is the authors say that it subsumes the existing concepts. And I feel like it's a good blanket term to use. So when exploring that space, I think it's a good starting point. So there are also many different socially responsible AI frameworks, and I think a lot of companies like Google and the world have their own frameworks, and this paper here references at least 20 frameworks, saying essentially everyone in the industry has their own framework. So is there a perhaps meta problem that we can solve here, where when we're developing these frameworks, what should we pay attention to? And they've cited these 6 points. So whenever you're developing a responsible AI framework, it needs to be broad across different ethical issues and aspects of data of life. It needs to be so this is a word I really struggle with, operational excuse me, in real world systems. It needs to be flexible to a variety of AI systems, use cases, and contexts. It needs to be iterative. And I'm going to say it again, it needs to be iterative throughout the life cycle of an AI system. So often, what we see is in the business managers, for instance, will prioritize this at the beginning of a project and then forget about it after day one. And we really can't let that be the case. Guided, so these things need to be easy to access, understand, and give evidence of how effective it is made public. And these things need to be participatory, meaning that they need to include the people who are affected by this research. So in implementing these kind of frameworks is quite tough. We have these AI governance frameworks to essentially implement a responsible AI for our AI in a responsible way. So this is a summary of one of those governance frameworks, and these are the stages in putting together an AI for health, AI in general products. So you can think of the first stage being organizational planning, second stage being use case planning, the third stage being the actual development of the AI, and the fourth stage being the deployment of the AI itself. I will one day master that word. Words are hard. So this is a lot. We're definitely not going to get through all of this today. So I'm going to make this a little bit more fun, turn this into a treasure map. I'm going to cherry pick some of these topics and go through them with you from my experience. Starting with legally responsible AI. So what are the laws and security concepts that you need to be aware of if you're going to be doing AI for health? Often these conversations will revolve around the data you're using and how that's regulated, and the models that you're using and how those regulated. And there's a little asterisk there. Nothing I'm about telling you is legal advice. However, I did consult with a data privacy lawyer for some of this information, so it should be good. Just for context, some of the data privacy laws around the world. We have HIPAA in the US, and that's specifically for health data. We have GDPR, and COPIA in South Africa. You can see data in 1996, 2016, and more recently 2020. And you can imagine that the way things are regulated across these spaces can be very different. Just some notes that wherever you find yourself, you have to be aware of these specific laws in your specific context, otherwise you can fail. However, globally, in terms of data protection legislation, only 66% of countries have any kind of data protection in force. And Africa is a bit behind that global average, where only 52% of our countries, as of 2021, have any kind of data protection laws in force. So this is a map of what that looks like, where the red, there's no law, orange, there's some laws in darkwood, and green, what are the next data protection laws in place. This is from a group called Health Advisory. They do base work for African health data privacy legalities. Go to check them out. So, while for each one of those terms, you need to understand the specific requirements and implications of the laws. What I'm about to tell you now is a very general summary across those. And my clicker has just stopped working.
Sorry. Should be active.
Cool. So I think what a lot of researchers will be familiar with is when you want to get health data, you would traditionally apply it to your resource ethics board or committee, and you can consider those being the data custodians, the ones who are responsible for the data, that need to be compliant to the data or information regulator of a particular country. So if you are a startup, in that case, you are the data custodian. There's no ethics board that you need to go through. There's no protection, extra data protection there. Essentially, what you should do is just collecting data. But if you're not compliant, you're going to be in a lot of trouble. So the only time that you actually have to go to the data or information regulator is if you're wanting to move health data across national borders. Otherwise, the onus is on you to be compliant until at some point when you get audited. Or if someone like files complaints and you get investigated. So you might be for the compliance. If you are not compliant, the penalties can be quite severe. So what you have to do to be compliant, and again, this is very broad and very general, but first and foremost, you have to know what your data is, what data you have, because your data subjects or your patients have laws that protect their participation in being a data subject. They need to be able to request the data, update it, delete it, or ask you to start processing. And if you don't know what your data is, then you cannot do that. Next, you have to make sure you establish security measures that are both appropriate and reasonable, that are both technical and organizational. So technical meaning your password as a firewall, in order to patient information, and realistically, you're always going to have a system admin somewhere that's managing, for instance, your cloud compute cluster that is going to have access is the fact that it is audited and that there are also then organizational controls around that. So for instance, does your building have a lock on the door? Does everyone in the company just have access to the data? Those are organizational measures. And if you are able to show this, and show that you have maintained and validated this, a good cadence, at least what I've been advised is doing an annual audit. So if you can show that you've done all these things, then that is helpful. And if you are breached, because these systems are very complex and your attack surface area grows, the larger your system becomes, the assumption is that it's almost impossible to guarantee something is impenetrable. So in the case that something was breached, the responsibility is then to notify the regulator as well as those affected. And depending on your context, those notifications can specific requirements. So within a specific time period, COPIA says ASAP, whereas GDPR says it has to be within 72 hours. Generally, you have to tell people what happened, as well as telling those affected how they can mitigate harm themselves. So all of that was just personal data. Right? Now we're moving on to health data. Health data is a special category of personal data with even more protections, similar to how you can consider something like data on children. Right? The data around your health has particularly greater potential to cause harm, and that's why we have these protections. So some of the non-compliance consequences there are massive fines, in excess of $500,000 to criminal charges, depending on what exactly is happening. So you can go to jail for mismanaging people's health data, and should be aware of this. Now, if this data is so well protected, how do we get at it? So you can make data accessible for purposes. However, in those contexts, you have to make sure that you get meaningful consent, where the purpose of the research is in plain language for the participants. There are some exceptions or special cases. Notifiable diseases is one. So if you have Ebola, that is a public health emergency. Unfortunately, your health data is not protected in those situations. There are a list of notifiable diseases in one can look up. That's just an example. And there are also cases where consent might be impossible or almost impossible to get. However, in those cases, we really have to additional safeguards and ensure that we've done that. Second big thing that you really need to make sure you're doing in trying to make data accessible is showing that there is some kind of public benefit or interest to doing this research. You can't just be like, I'm collecting health data because it's my part. So within that space of data accessibility, what options do we have for making our health data more accessible? So the traditional mechanism here is data de-identification. I'm sure a lot of you may be familiar with this. This is where we take certain fields of the data and we either remove them or we perturb them. So the patient is in their 30s, we perturb that 3 years in either direction and remove as much identifying information as we can. However, these the identification is not perfect. And while things like HIPAA will specify, let's say, like 20 standard fields and how to identify data, regulation around the world isn't as consistent. So, for instance, COPIA has a much more general open to interpretation definition of what the identification of data is. And these are also vulnerable to certain like re-identification attacks. So when we're using the identification, we really have to be conscientious about the context and case in which we're using it. And the same goes for privacy-preserving AI, which is very new on the block. Again, these are 5 hot topics like federated learning, secure multi-party compute, different privacy, homomorphic encryption, and all of these necessarily have trade-offs. Homomorphic encryption algorithms are still very inefficient to do on like very large data sets. Federated learning if you're just sharing weights or something like that, you can also get information issues there. Not to mention bias for data set which you want to see, or data poisoning. There's a lot that can go along there. However, I do think that it's promising that we are seeing a lot of work in these spaces, and I don't think there is like one single solution. I think that combining reasonable day-to-day identification with some forms of privacy-driven AI is probably a sensible way forward. But it's good to know that these exist and that they can be used. So moving on to models for how do we regulate these models? So machine learning models tend to be referred to as software as medical devices, and that's how they're regulated. We have the FDA, which is in the US. We have the South African Health Products Regulatory Authority, and then we also have the International Medical Regulators Forum. I just like to note that there are no African countries on that International Medical Devices Regulatory Forum. We should try and change that if we can. And the regulatory measures around machine learning, as a medical device, is slowly sparking globally. So what I'm going to do now is just go through the FDA does at a very, very high level, and hopefully this will inform us also about if we want to regulate things within our own context, because a lot of companies will first try to get their algorithm either cleared or approved by the FDA, and then that makes it a little bit easier in their own context. But if you are going to deploy it in your own country, you have to get it regulated in your own country. So there's something to be hopeful about. These are two stats on how in the last couple of years we've really seen an uptick in things that have been either cleared or approved by the FDA. We can see that radiology is one of the more popular spaces there. So these things are getting passed through, and we hope in a responsible way. Time will tell. So at a very high level, we can consider the FDA as either providing clearance or approval for a particular algorithm or for any kind of medical device. What determines if you're going for clearance or approval are how risky your devices are. So they stratify this as the class 1, class 2, class 3 in terms of risk. So you can think of like class 1 as being something like a band-aid or something like fairly innocuous. Class 2 might be something like an automated blood pressure cuff. And then class 3 is anything where you have intervention in people's health, whether it's with medical goods or let's say in the devices context, like a pacemaker, something where there's like serious threat to someone's life. So you'll see that in the approval case, you have to have clinical trials, which are a fairly lengthy, standardized process for approving both devices and medication. And what I've highlighted in light blue there are the things that machine learning models, by and large, at least in the diagnostic space, have been regulated under. So they're generally regulated under class 2, not all the time, but just as a trend in that space. We also see instead of clinical trials, we see more general clinical studies. So clinical trials are a subset. To the point of the clinical study term there is because it's more general, the flexibility for what constitutes a valid clinical study is extremely in clinical trial. So as a startup, that is an easier route. Also, if you're a startup and you're looking to try to get through FDA as many things you can, you have the option of doing like a completely new idea, like de novo, or extending an existing idea or algorithm. Extending something that's existing is far less lengthy and expensive to endeavor to go through. Also, something the FDA really considers in terms of the risk profile of the algorithm, who the end users are. So, for instance, with your diagnostic ML tool going to be let out in the wild to the general public, something like in the counter space, or are the end users going to be health professionals? And generally, if you have that layer of health professionals between your algorithm and the general public, that comes across as less risky, so you'll probably have a better time with that's the case. You really have to think how much money and time will spend putting together your algorithm for regulation. Good to know FDA has things called Q subs, which means you can pretty much indefinitely and for free request feedback from the FDA. The caveat there is it's a lot of paperwork, and you generally need an FDA consultant to help you with this process. There are some resources around there. You can try to do it yourself. Medical Advice Academy is a good one. Cool. So moving on quickly, because I think only about 10 minutes left until the questions. We're looking at like our business value frameworks and like how we actually do the model. I think we really need to, in the healthcare space, in the low resource space, think about what is our clinician acceptance threshold if we are making algorithms for medical professionals to use, because if your tool isn't better than pen and paper, you're really going to struggle, or whatever is existing already. What is the error tolerance rates for your end users using your algorithm? I think one of the things that people very often forget about is just the ergonomics of using the product. So UX is super important, as well as considering what physical environments is this tool going to be deployed in. Is it going to be in an ER? Is it going to be in a ward? Are they going to be like alarm signals going off that's really loud, so that we're trying to use something like natural language processing and transcription of complicated medical terms, will that soundscape affect what you're trying to do? And the thing here is also with English structure assumptions, and I think this is very relevant to our current state in South Africa. Are you going to have consistent power? So if you're really entering in like patient information and the power cuts, and you're like half an hour into documenting this patient, and none of that stuff money can save, that's a big problem and can really often be overlooked. So by just taking a pause before you start building and understanding like where these models are going to exist, I think you can save a lot of time and money in avoiding rebuilding systems because we've optimized the system along like for assumptions. Looking at like more in like the organizational planning and like some of the processes there. Hiring is super important if you want any of this to work. And what we've seen in trying to deliver machine learning products is you really need either like highly skilled machine learning engineers or MLOps engineers, which are really a few and far between. I know our team, like you, we're all machine learning engineers, and it's extremely hard to hire for our team. Either, I mean, very rarely do we find anyone with all of these skills. Either we'll find like a data scientist and train them to do DevOps and cloud engineering, we have to take a software engineer and try to train them in data science. Generally, what I'll say here is you want to try and think about what interdisciplinary team do we need to put this together. And I don't really tend to be too bullish on any kind of business workflow in general. So Scrum or Kanban or whatever, whatever works for your team works. But because of the very interdisciplinary nature of how these teams tend to look, I do think that this Conway's law tends to be quite applicable, where the team structures in your organization are going to be reflected in your software. So if you have like cloud engineering team and research team, and the products are going to look compartmentalized like that. And especially if we're looking at like more of like a microservices architecture, where you need input from the researcher, DevOps person, cloud engineer, having cross-functional teams, perhaps in addition to the more traditional team structures, is something I really think is impactful. Moving on to just some of the tools technologies and moving on. term you're here in these spaces, production and healthcare or machine learning is MLOps, machine learning ops. I think the third term group might be computational research ops, because it's not just machine learning models that we can use, it's like statistical or like digital numeric modeling applicable to us. And broadly speaking, I would say that the goal of MLOps is to increase the rate of end-to-end research, as well as increasing the reliability of responsibly served models. And you can see the image down there is an extension of like a typical DevOps cycle, extended with machine learning. So I think a lot of researchers will be familiar with this as like an ML pipeline, and technically this is MLOps. However, fully fledged MLOps systems look a little bit more like this. And really only now are we starting to see these architectures being consolidated. And this is from a very recent, and I particularly like this one because it also describes who is doing what in these different cases, as well as they talk about different zones, like this is the product initiation zone, or the research zone, or a deployment zone. However, this is just like a lot to take in, and I think the best way I can like describe this is half of it, your assumption should be you're going to be doing research and that experimentation. The other half, you're going to be doing some kind of reliably and responsibly deployed product. And the reason I make this assumption is because your software stacks are going to look very different in most places, because your goals that you're optimizing for are generally different. So for instance, in production, like latency isn't something you really need to be conscientious about. When your customer clicks a button, does the inference very, very quickly, and you'll probably be using a stack that is optimized for much, much lower latency than if you're in the research space. There, often you'll probably be starting with some kind of like batch processing, and the ability to like rapidly look at first, I would advise at least as simple models as you can on the data that you're looking to experiment on, and then sort of going to more complex models. So for instance, if you're starting with deep learning, especially in the healthcare space, you're probably doing it on because you can get really models, and simple models are more extendable. These are just some principles that are applicable across like both of those spaces, where you're going to be looking at like continuous integration, continuous development, so CI/CD. The thing is really need to be reproducible. You want to make sure that there is collaboration across those spaces as well, because the communication that it has can really believe directly. So another thing I'd like to mention, and again, I'm running out of time, so this will be very quick, is just the commoditization model. I think we'll be aware of that in this space, where this is what we call a boarding map, where on the left we have products that are in the prototype phase, and on the right we have things that have been commoditized or like made very cheap and mass produced. So the cost of the business for things on the left are way more than the cost of the business for things on the right. And at least traditionally we've seen it like people making custom built models, but more recently models have moved into this model space. So if we are initially not using off-the-shelf models to get started, and you're custom building your models, you might want to check yourself on that, because things like paper to code or like coding base, they've really commoditized what it is to use something like a transformer to make use of that. And we're seeing a similar thing with platforms. Here's just a good tool I found for assessing the trade-offs for when you're deciding whether to build or buy a tool. I particularly like this because they give big summaries of like the help, might consider the help of a tool at a glance. And here's an example of one that's not doing so well, so there's not much activity in this tool space. So I wouldn't feel comfortable trying to motivate for our company to use this. Very popular, lots of stuff in GitHub. yeah, and probably that. And you like talking a little bit about opportunities and some of our endeavors in the space and why I think collective action is really needed to help shape the AI to help policy in Africa. And it's all because, as we've seen, there isn't that much policy there just yet, and it is busy being discussed. So we should really do what we can to make our voices heard. And when we're doing that, it's really important to remember that just educating policymakers is important. So, spaces and realizing that bite-sized policymakers also tend to really like metrics. It helps to have a compelling narrative, making stories more personal, and again, having a community that can help rally around these drives to update our policy is super important. So on that, I'm going to talk very quickly, because I am take some time, on our grassroots participatory science communities and what we've seen there. So I think these are some of the communities that have helped co-found. What we mean by this grassroots bottom-up participatory means that entire communities who are affected by the research are invited to be a part of these communities. We broadly categorize these communities into what we call affinity-based, couple-based, or event-based, where, and again, this is just like a small sample of some of the communities in this space. These are all for machine learning and data science. But we have seen these emerge for the last 5-6 years. And in the affinity space, these are groups that were traditionally represented. So, machine learning, AI, brain AI, and AI. And I think there's a lot that we've learned in how these groups have organized. And from that, also because membership in these groups isn't mutually exclusive. We see members participating in communities across the board, and that really helpful for knowledge sharing, as well as just learning how to be effective and social online when trying to conduct research or do something like collaborative paper writing. We see other communities who are organized around topics. So a lot of these have been in the natural language processing space, so you see that things like the or like the Google AI, or NLP, and all that things in NLP. A lot of great work being done there, as well as ones that are more general and more collective, perhaps, as well as event-based grassroots efforts. Chris Fourie mentioned the neuroscience and user, deep learning Baba, one. There's a great initiative in Nigeria to AI Saturdays, where they're training hundreds of students on Saturdays for like a couple of months to this is in person to collectively go through AI courses. Neuromatch is doing some great stuff, and I presented this in another extra wonder. They're using data extra as well. So we have sort of developed a framework for grassroots participatory research, and the idea here was to enable any small group of individuals with scarce resources to develop like sustain an online community within space of about 2 years. And you can think of that as perhaps like postgrad students, literally like 4 or 5, just getting together and meeting maybe once a week, once every 2 weeks, and building iteratively up from there to a space where they're able to produce research. These are some of the values or priorities that we found after surveying these 3 communities, like Massacana, and Roya, which is a community for computer vision in Africa, where Massacana is natural language processing in Africa with underrepresented languages. So some of the values here are community first. And what does that mean? People with papers. You can imagine a situation where we're all pushing for a paper deadline, and because this is online and meetings are already fairly noisy, and this is all voluntary work, sometimes people become available, and that can be quite frustrating. This being very intentional about the community approach means that in those cases, it's more easier to say, well, hold up, we're going to try and prioritize community building and capacity building over publications, and rather like let's try for another conference to put that deadline instead of trying to push our colleagues into a space where they're going to burn out or not grow. And what we found really is if you put enough people or academics, let's say, in a room together, they're going to write a paper. So yeah, and out of time, so trying to do that. Just some stats here. So this is what our Sunday morning biotic community looks like. One of the things about different levels of participation. We've got like a full building team. We've got individuals who are contributing to projects and events. We've got individuals who are participating in online chats. So about 200 people in our Discord. About 60 of them being active in the last 3 months. Which you can think about like a distributed research lab. 60 is quite a big number. And then we also provide a space for people who are just exploring. So we run like various seminars and things. And we really branched off from the Madison County community, and you can see that they are really flying. They've raised over like $700,000. They sustaining an African MLP workshop that's been holding in multiple places as well. They've got 24 publications where we only got about 4, at least the model works. And they also won the Media Paper of the Year. So this grassroots participatory approach does work. And there are about 2,000 people in their Slack and exploring. So I think that there's like a lot of opportunity to complement this with our existing research efforts towards communities helping each other. We started this year with grassroots party, so there are actually 4 communities there on papers. But I'm also on the community for the youth in Nevada. There's about 30 African communities that are going to be approaching this year to invite to be members of this. And the 2 goals here are essentially mutual support for these grassroots communities together, as well as helping to incubate and bootstrap new grassroots communities. So if you are interested in starting one, please contact me and we're happy to talk. And that is my talk. Thanks to these individuals for some of the research for this talk. I really appreciate that. Yeah, any questions in discussion? We've got time. Yes.
First of all, the meeting that I think is not saying and my other question was in how the ethical students when we have public domain data, secondary data, so that the question is like where will we store the data? And anyone that access that data or casual or UCR repository, whatever, why the process,
Sure. So for that second question, I'm not sure it's a good question. I can answer to that because that seems like additional overhead for data that's already public. I don't have an answer. Oh, okay. And then on the first one, the rocks, there is a distinction between minimized and de-identified data. I think the definition of anonymized data means that there is no possibility to de-identify. Whereas de-identify, again, this might change depending on the context. Pick on some processes to de-identify that data. Whether that data is anonymous, we'd have to like stress test that and something like I don't feel that's the rigorous distinction that I might be able to find the people who online chemistry.
So with regard to that, obviously the data itself is using the made something related. And once you look at those analysis in the data, you may capture the data in ways against us in for example, as part of the argument of the full data. And that is a way to introduce additional vulnerability to the groups. So that's because my website data is analyzed in school. It needs to be stored and curated in a way that is done in a responsible manner. So if there is analysis of the data like an old school example from like an IoT experiment. In particular, the group was identified and then kind of for example. And then once that was in the public domain, the insurance company didn't want to provide that proof with a very So in the analysis phase, when you package your data and then you make it available to there is a mechanism for interference with the community and the
Sorry, Chris. We have a question online.
Just the subsequent narrative was there on the one that
I would also suggest that there could be potential for that person to outside of the system because of the way that the data is stored. You may make a copy of the data and say, put it on your own server. But let's say somebody hacks into that data, but it's where you've taken it all and you've now stored it in your own server. They happen to go over and deduct that data. That may be why there's a question around how that new data is imported and located. Because that may also introduce some people that are never stored the ones to ensure the
rule of data for whatever it has to be. And people think they have to have the data itself.
Remembering that if it's stored is not going to always be recurring, but if it's stored at an institution, it's not looking at the people for the data for the team or elsewhere. They're looking at the individual data for security and making available for data access to data on down the line. So they would want to know the answer to the question that all the stages that would be my guess if I was sitting in the I would want to know the initial stage and the stuff is relating to being making available to the data access and how that influence it.
Do we have any research projects out there relating to AI modeling of biochemical molecule and the field of proteomics at large?
Yeah, I think AlphaFold is probably a great example of a project in that space. From African companies, if you look at Institute, they've got a suite called Deep Chain you can look at. But I think if you just generally search, you will find projects in this. And one, because there's just so much data coming out of the genomics and proteomics. So I think individuals have really like when the data is accessible, work in that space tends to flourish. I personally am quite excited for there's a lot of stuff in biology that's described as graphs. So I'm quite excited about what we're going to see from like graph neural networks in biology. But yes, you'll definitely be able to find it.
Awesome. I think that's it. We don't have any more questions.
Anyone here have any other questions? Yes. So Google's DeepMind just recently merged for Google Brain. The AlphaFold is doing some really good stuff. They broken some traditional benchmarks like 2 years in a row. They smashed it up. But what's also quite great there is they opened up their protein catalog. So I haven't used it myself, but I'm aware of it.
So Chris, thanks. Yeah, so thanks very much for running through today. So just a little thank you given to say thanks very much for your time and effort and for coming in. Say very big thanks to Chris, who's lost audio in the last little while for sharing the session, and a big thanks to the other Chris for today's seminar. Thanks very much for your time. Really very insightful seminar.
I'm really glad that I came in person.
Thanks very much.